So we're going to be looking at dividing integers and decimals. Now, an integer, we talked before, there's just basically whole numbers. We have positives and negatives, but I'm just going to be looking at division. Now, fancy way of how to say division is quotient. So when I ask you guys for the quotient, basically I'm asking for the division of two numbers. Now, the dividing, the sign for division, there's two ways I'm going to use it. You guys see here number 16, that little line with two dots, one on top, one at the bottom. That's one sign of dividing. Another way I'm going to also use it is writing the numbers as a fraction. I'm dividing the number on the top divided by the number at the bottom. And then on number 16, when I use that little dot is dividing the first number by the second number. So now what does that really mean? So let's take a look at number 15. What does division really mean? You guys have seen the show The Price is Right. You know, they say get close to the number without going over it. They usually ask for a price. What's the price of this without going over? And then you're trying to get as close as possible. Same thing here. Right, for this moment, let me ignore the signs. I know there's negative signs, but for this moment, let me ignore the signs. I'm gonna write this 37. So let me write 37 divided into 1,332. So I want to know how many times does 37 go into 1,332 without going over? I want to get as close as possible, but without going over. Now, the number seems a little too big, so let me look at numbers little by little. 37 is a two-digit number, so I look at the first two digits of my number inside. And then I ask myself, how many times does 37 go into 13? Well, I can't, right? Because 37 is bigger. So, okay, instead of looking at two numbers inside, let me look at this as three numbers. Then I ask myself, how many times does 37 go into 133? Then I can figure things out. Well, I can take a guess. How many times does 37 goes into 133? I ask myself, I think I decide, let me take a look. What if I tried, because 37 is about 40, right? 133, I'm thinking about three times. I'm gonna take a guess. It seems like three times. I'm gonna take a guess. Now, 3 times 7 is 21. So I write that the 1 and I carry the 20. 3 times 3 is 9, plus the 2 remaining is 11. So 37 times 3 did not go over 133, so that's good. They didn't go over, that's the first thing. Then I'm going to subtract this. 133 minus 111. If the difference is less than 37, awesome. I got as close as possible. If the difference is more than 37, I didn't get close as possible, so I guess 3 was not a good guess. Okay, so let me subtract this. On the units, 3 minus 1 gives me 2. On the tens, 3 minus 1 gives me 2. And then on the hundreds, 1 minus 1 gives me 0. So my difference is 22. Good. It is less than 37, so I did get as close as possible. Now let me bring down the next number. And then I'm like, oh, 37 into 222. Well, 37 is about 40. 222 is more, a little more than 200. I know 40 goes into 205 times. So I'm thinking, oh, will 37, how many times will 37 go into 222? Let me take a guess. Sometimes our guess might be too small. Sometimes our guess might be too big. I'm just gonna take a guess. I'm thinking probably 5. Right? Again, I could be right, I could be wrong. Just start with the guess. So let me try the 5. 5 times 7 is 35. Carry then the 30. 5 times 3 is 15. Plus the 3 I was taking is 18. Let me subtract this. Now 2 minus 5 I cannot do, so I have to change this to a 1 and borrow 10. Now 12 minus 5 is 7. Here, let me borrow 1 to make this 11. 11 minus 8 is 3, and then 1 minus 1 is 0. So my remainder is 37. Oops, I guessed that a little bit too short. Right, 37 goes in it 5 times, but then I have a remainder of 37. So that means I can go with 37 one more time. So I'm like, okay, let me raise my 5. Let me put a 6. And there you go. My answer will be 36. Why? I tried 5. My remainder was 37. So could I have gotten one more 37? Yes. So I changed my 5 to a 6. I'm going to say my answer is 36. Then I take a look at my signs. I have 2 negative signs. Now, usually when the signs, the rule that we say it is when the signs are the same, my answer is positive. So 2 negatives, 2 positives. If the signs are different, then the answer is negative. Now, one thing I'm going to say, if that is difficult, draw a triangle here, and I'm going to draw 2 negatives and 1 positive. And then I'm going to say cancel the 2 signs that you use. There's 3 signs altogether. Cancel the 2 signs that you use, and whatever's left, that's basically your answer. So let me cancel the 2 negative signs that I use. My answer is positive. So my answer here would be positive 36. Might be like, what if I had a negative with a positive? All right, let me draw this. Cancel a negative, cancel a positive. My answer will end up being negative. Okay, so hopefully that triangle does help you guys a little. Let's take a look at here, number 16. 1034 divided by 22. Okay, so let's take a look. 22 into 1034. Now I start with 2 digits. 22 goes into 10. Not really, because 10 is smaller. 22 goes into 103. Well, 22 is about 30, right? Or about 20. 22 is about 20. 103 is about 100. So I ask myself, how many times does 20 go into 100? Sounds about 5. Again, I'm gonna take a guess. We're gonna start with a good guess. My goal is trying to get as close as possible without going over. Now, can we make mistakes on our guesses? Of course, it's just a guess. So let me try a 5. Let's see what happens. 5 times 2 is 10. Write down a 0, carry down the 10. 5 times 2 is 10, plus the one that I was carrying is 11. So 103, I was supposed to get 103 and I got 110. Oops, I went over. So I guess 5 was not a good guess. Now, I intentionally got this wrong because I want you guys to be able to just give it a shot. Don't be afraid of making mistakes. If 5 was a little bit too high, well, instead of 5, let's try 4. At least we had a good place where to start. 5 is too high, try 4. Now 4 times 2 is 8, and 4 times the other 2 is another 8. Okay, 88 is less than 103, so yeah, I didn't go over. Remember, my goal is get as close as possible without going over. All right, let me subtract this. Now 3 minus 8 I cannot do, so from this 10, let me borrow 1, so this becomes 9, and this becomes 13. Now 13 minus 8 is 5. 9 minus 8 is 1. I know I'm good because my remainder 15 is less than 22. So far, so good. Let's bring down this 4 here. So then I'm thinking, okay, 22 into 154. Okay, 22 is kind of like 20. 154, I'm thinking could be like 140, 160, because 20 will go into 147 times. 20 will go into 168 times. So 7 or 8. Let me take a guess. Let's try a 7. Why not? So 7 times 2 is 14. Carry the 10. Now 7 times the other 2 is 14, plus the one we were carrying is 15. Let me subtract this. 154 minus 154. Well, that's easy, right? It's 0. My signs, when I look at my questions to begin with, They were both positive. All right, my answer is positive then. So my answer here is 47. 1,034 divided by 22, it's 47. Now, what if we have decimals? We're going to treat it like the same thing we do integers. The only thing, so let me write this as 7 goes into 26.6. The only thing is that my number outside cannot have decimals. If I have to move my decimal point somewhere to the right, do so. But again, my number on the outside, so I'm looking at this number, the number on the outside cannot have a decimal point. Inside, it's fine, but outside, no decimal point. So we're good. So my question is, can 7 go into 2? Oh, actually before, I know my answer is going to have a decimal point. Let me bring up my decimal point straight up. So then I just start dividing. I'm going to ignore the decimal point for a minute. I know 7 cannot go into 2 because 7 is bigger than 2. But can 7 go into 26? I know 7 times 4 is 28. So I'm not going to say 4. I'm going to say 3. Because 3 times 7 is 21. Again, I'm trying to get as close as possible without going over. Kind of like the game The Price is Right. Okay, so let me subtract this, right? 26 minus 21 gives me 5. Good. Let me bring down the next number. So now I'm thinking 7 into 56. I know my timetables of 7. I know 7 times 8 is 56. Oh, I guess that gives me a perfect answer, right? 7 times 8 is 56. So I got the perfect number without going over. My remainder 0. Now, when I take a look at my sign, they were both positives to begin with. My answer is going to be positive 3.8. Now, looking at number 18, I'm going to ignore the signs for a minute. I don't worry about the negative signs for right now. I'm just looking at 4.3. It's going to be divided into 68.8. The number on the outside cannot have decimals. Okay, so what I'm going to do, I'm going to move the decimal 1 point to one place to the right. Whatever you do to the outside of the division, do it to the inside as well. So let me move my decimal point one place to the right on each. So I get 43 into 688. Let me bring my decimal 1 point, let me bring it up. My answer might have a decimal point. So I'm thinking, can 43 go into 68? Yeah, it can go in one time. 1 times 3 is 3. 1 times 4 is 4. When I subtract this, let's see, 8 minus 3 is 5. 6 minus 40 is 2. 25 is less than 43, so we're good. Let me bring down the next number. Now I'm thinking, all right, 43 into 258. Okay, so in my mind, I'm thinking 43 is kind of like 40. 258 is kind of like 240, right? Because then I can divide this by 6. And I'm thinking, okay, 40 into 240 goes in 6 times. Let's see. 6 times 3 is 18. 6 times 4 is 24, plus the one we were carrying is 258. I was supposed to get to 258. Awesome, I got to it. Now, my answer is 16. There's no more numbers. If my remainder was not 0, then continue. Continue as far as you need to go. But I'm going to stop here, 16. Now, let me take a look at the signs. One of them is negative, one of them is positive. So I do my little triangle here. 2 negatives and a positive. I cancel a negative sign. I cancel a positive sign. So my answer will be negative. In this case, negative 16. All right, that was nice. That was easy.